In this video, we're going to look at the derivative of some trigonometric functions. We already know that whenever we differentiate x, we're going to get 1. Whenever we differentiate sine x, we're going to get cos x. Whenever we differentiate cos x, it means we're going backwards. We're going to get negative sine x. Whenever we differentiate tan x, we're going to get sec square x. Whenever we differentiate negative cot x, we're going to get cos sec square x. The reason is because whenever we differentiate cosec square x, we're going to get cot x. When we differentiate sec x, we're going to get sec x tan x. Whenever we differentiate negative cosec x, we're going to get cosec x cot x. Whenever we differentiate negative sine inverse of x, we're going to get 1 over root 1 minus x squared. Whenever we differentiate cos inverse of x, we're going to get negative 1 over square root 1 minus x squared. Whenever we differentiate tan inverse of x, we're going to get 1 over 1 plus x squared, and so on. Whenever we differentiate cot inverse of x, we're going to get negative 1 over 1 plus x squared as well. Whenever we differentiate sec inverse of x, we're going to get 1 over x times root x squared minus 1. Whenever we differentiate cosec inverse x, we're going to get negative 1 over x root x squared minus 1. And so on. Whenever we differentiate exponential x, we'll still get exponential x. Nothing changes. Whenever we differentiate log x, we're going to get 1 over x. And whenever we differentiate a raised to power x over log a, we're going to get a raised to power a. So these are some of the basic quantities that we need to know. Now let's look at some questions. This question says differentiate y equals tan x over x. Whenever you see a value or an entity over another one, what comes to your mind is quotient rule. And for us to use quotient rule says that we'll keep one constant, differentiate the other, minus we'll keep one constant, differentiate the other, divided by v squared. This is quotient rule. So dy dx, that is quotient rule. Now here, the one on top is our u. So we say u is tan x. If we differentiate tan x, which is u prime, we're going to get sec square x. We're going to get sec square s. The one down is v, so our v is x. If we differentiate x, that's v prime, we're going to get 1. So this can be substituted into this arrangement. So our v is x, so we write x. Our u prime is sec squared s, so we write sec squared x, minus our u is tan x, we say tan x. Our v prime is 1, so we say 1 over v squared. Our v is x, so x squared. Now, the next thing we do is just to simplify it by saying x sec squared x minus tan square x times 1 gives you tan x times 1 gives you tan x over x squared. That is the answer. This question says find dy dx of sine x over 1 plus cos x. Whenever you see this of something over another entity, it means quotient rule. And remember, our quotient rule says that we're going to keep one constant and differentiate another minus keep one constant, differentiate the other, divided by v squared. So keep v constant, differentiate u, minus keep u constant, differentiate v over v squared. Now, having gotten that, we call this u, call this v. So we say u is sine x. And if we differentiate sine x, which is u prime, if we differentiate that, we'll get cos x. Now, our v is this. So we say our v is 1 plus cos x. Now, since we have gotten that, our v prime will now be, if we differentiate this, we'll get 0. This, if we differentiate cos x, we're going to get negative sine x. So negative sine x. We can now plug it into this system, this format. Our v is 1 plus cos x. Our u prime is cos x minus our u is sine x. Our v prime is negative sine x. Now, over v squared. This is our v, 1 plus cos x all squared. Now, since this and this multiplication, this and this multiplication, so we multiply out. Cos x times 1 will give us cos x. Cos x times another cos s is going to give us cos square x. That's for this side. Here we have negative sine x times another negative sine x will give us positive sine square x over 1 plus cos x all squared. So sorry, here will be plus, that is here, because we've already multiplied it out, so it's plus. Now we need to recall, if we look at here, we have cos square x, here we have sine square x. We need to recall a fundamental identity that says that cos square x plus sine square x is equal to 1. So here and here, they are equal to 1. So we'll say cos x plus 1 over 1 plus cos x all squared. Now, since we can't add two of them, we can rearrange it to make it look like this by saying 1 plus cos x over 1 plus cos x squared. So it means one of these will cancel one of this. So we'll have 1 over, that the dy dx is 1 over 1 plus cos x. So that is the answer. Please remember to subscribe to my channel if you haven't. Thank you.